Hey everyone, so today I'm going over how to factor the difference of perfect squares level 2. It's very similar to level 1. The numbers might be a little bit bigger, you might have more than one variable per term, and the exponents might be a little bit bigger. But other than that, everything is pretty much the same. So here we have a difference of perfect squares because 1 is a perfect square, 121 is a perfect square, and any variable that has an even exponent is also a perfect square. So the first thing I'm going to do is I'm going to find the square root of 1, which we know is 1, because 1 times 1 is 1. Then we're going to find the square root of 121, x to the 6th, y to the 4th, this whole thing. Now, the square root of 121 is 11, because 11 times 11 is 121. And then with the variables, what you're going to do is basically take your variables and divide them by 2. So x to the 6th, the square root of that is x to the 3rd. Because x to the 3rd, I'll show you over here, x to the 3rd times x to the 3rd. Here you would add your exponents. This is a little messy. Let me fix that up a little bit. X to the 3rd times x to the 3rd. You would add your exponents in this case. 3 plus 3 is 6, so that's why the square root of x to the 6th is x to the 3rd. So we're going to do the same thing with y to the 4th. Take that variable, divide it by 2. We're going to get y squared. Now you make both sets of parentheses. We're going to have the first term go first, so 1 is going to go first in both. And then we're going to have our 11 x to the 3rd y squared go second in both sets. Oh, that's a 2. So 11 x to the 3rd y squared, and we're going to put a plus and a minus, and that's it. That's how we factor the difference of perfect squares, where the exponents might be a little bit bigger. We might have more than one variable. Remember, the plus and the minus doesn't matter which one goes first. Either one will work. Multiplication is commutative, so you can move stuff like that around. We're going to look at one more example just to really make sure you guys have it. So we're going to factor this. This is the difference of perfect squares. We have two perfect squares here, and we have a subtraction sign in the middle. So the first thing I'm going to do, square root of 144. X to the 4th. The square root of 144 is 12. And the square root of x to the 4th, take that exponent, divide it by 2. So it's going to be x squared. My computer is, okay. We're going to do the same thing, but with 9y to the 4th. The square root of 9 is 3. We're going to take that exponent, divide it by 2. We get y squared. Now we're going to make our set of parentheses. Our square root of the first term is going to go first, so we have this 12x squared first in both sets of parentheses. And then we have this 3y squared. That's going to go second in both sets. And then a plus or a minus and a plus. Like I said, it does not matter what order that's in. And that's it. An easy way to check this would be to use the distributive method or the box method. You could FOIL it out, see if that's what you end up with in the beginning. And we did everything correctly here, so we should. All right, good luck.